fish swimming at a speed v relative to the water, the energy expenditure for unit time is proportional to v to the power 3. Okay? That means, fish swimming, against a water, right? Water stream. So as v speed, you can think. It's proportional to v to the power 3. That's why v to the power 3 is here. Okay? And L is called proportional constant. Right? Let me see what it's there. It is believed that migrating fish try to minimize the total energy because they need to swim, far away or maybe as long as possible. Okay, they try to minimize total energy required to swim a fixed distance. If the fish are swimming against current, the water stream u, so you have fish has to swim more than you, otherwise it's go with the stream, right? So the v should be more than u, that's the condition, to swim across the stream. Okay, then the time required to swim a distance L is this. This is really, the L really is, I think it's a proportional constant. A is the proportional constant. Okay, so it's, I think you know that in physics normally you find out what are the connections between your variables, like E is proportional, like this is the proportional symbol, and it's proportional to V cube L V minus U. And to make it equal, you have to have a proportional constant. That's what A. Okay. So you can find the value of A by doing experiment. Okay. So we don't care what is that A is. It's different from different species of fish. Okay. But let's say just A. Okay. Where A is the proportional constant. And total energy is required to swim the distance is given by this. So if the fish want to travel like 1 mile, you have to put 1 here. Determine the value of V that minimize E. So you have to figure out the L is the constant because the fish has to swim like certain length, certain distance, and A is a constant. So on the V is the current, the water stream, okay, the velocity of the water streams. U, the only thing that fish can change is, its velocity, the speed. So V is the variable. Clear? When the others are constant. Okay? So we know all the other variables, all the A, L, U are constant. So you have the function, the energy as a function of the speed of the fish, okay? A V cube L V minus U. I need d E over dV, which is E dash V. I'll give 3 minutes. You can try. Determine the value V that minimize the energy. Because fish has to make sure to find the velocity which minimize the energy. What is the minimum velocity that fish need to use to travel this L distance? Can we take the derivative? Is it again? That's again quotient rule because we have V there and here. AL you can take out if you want. Okay. Can I write it like this? Okay. Before you take the derivative, you can think it's like AL V cube V minus U. This is constant. It's like number. You can. It's like a 10 or 20, you can keep it outside and only work with the brackets. Take the derivative and see how AL, I know the bottom is V minus U square. Right? Good. V minus U times the derivative of V cube. V minus U times the derivative of V cube is 3V2. Good. Is it clear, look? Good. What's the problem? So when you have minus 1, because you take the derivative, this times the derivative of V cube, and V cube times the derivative of the bottom. What is the derivative of the bottom? It's just 1, right? So it's just minus V cube. Yeah. Clear? Because if you take the derivative of the bottom, like V minus U, if you take the derivative of V minus U, it's just 1. Clear? Denominator times the derivative of the numerator minus numerator times the derivative of the denominator. What is the derivative of the denominator, Luke? So see? So if you take the derivative of this, it's just U is a constant.
Just 1.
Just 1 because you differentiate just V. Okay? U is the the speed of the water. If the fish are swimming against a current, U. Current means like U. Okay? Right. Now you have to simplify it a little bit. AL, I'm going to take this guy. This is, you can see it's mathematically, can V be equal to U? No. If fish swim at the same speed as the current, it cannot swim, right? It's like a still. That's why it's coming in the middle, and you can clearly see they are not equal. They cannot equal. Of course, they give the condition that V is positive. I mean, V more than U. Otherwise, it's not really practical. Okay, it's not practical. Otherwise, okay. So since V is more than U, this is positive number. Of course, it's a positive anyway. And it's never, I want to make sure it's never 0. It's never 0 because of the condition. And if I simplify this, 3 to the power 3V cube, yeah, and 3V2U This is the really thing that I want to consider. This is my numerator, okay? But I still keep that I want to simplify this one a little bit. AL V minus U square. I'm still working with my E dash, okay? E dash V. E dash V. Yeah, let me write it as our thing. 3V cube, it's 2V cube minus 3V square U. What do you think? I kind of, I can quickly simplify, but I want to show you all the cancellations and write all the steps. But if you get, a little bit of, more practice and more, if you can see the quick cancellations, you can skip certain steps, okay? You don't need to do all those things. So I can take V to the power 2 out, because V to the power 2 is positive, so I can take the V to the power 2 out, and V minus U. So if I take v to the power 2 out, it will be 2v minus 3u. Everybody agree with that? Because if I take v to the power 2 out, it's become 2v. This become 3u. Because I take v to the power 2 out. You may ask, can I take? Yeah, common term you can take out. And I'm the only possibility that my derivative can be 0 when my v become, you can't still see that, but let me take 2 also out, okay, at the same time. I'm going to take 2 out from this, but when I take 2 out from this, I have to write like this. So, is that clear? It was 2 and 3 there, but I take the 2 out, so this, you can multiply 2 by this to get that. 2 by this to cancel out 2. Is that clear? Because the reason I write like that, then you can clearly see what should be the speed of the fish. Can anybody notice what is the speed of the fish? It should be 3u over 2. If my v become this number, my derivative is 0. Clear? So that means that is the extreme point. That means I don't know whether it's a minimum or maximum yet, but I can discuss that. But at least I know when fish swims 3u over 2 speed, that means 50% more than the current speed. Like 50% more than means this is like v equal 3u over 2. This is the extreme point. This is like 1.5u. 1.5 means 50% more than u. This is v is, you can see v is 50% more than u. Because it's like 1.5u. Experimentally, it's proven that this result has been verified experimentally. Migrating fish swim against the current at a speed 50% greater than the current speed, so that it can minimize the energy. But I still don't show you what happened less than or more than. Okay, so I'm going to draw the same kind of picture. Okay, this is the energy now. This is the speed of the fish. Okay. Any questions, by the way? Any questions? I will not put this type of question in the text, okay? So it's because it's too long. I can give you a number. That's why you learn the derivatives. I can give you x to the power 3, 5x to the power 3 over 6 minus x to the power 2, something like that, which resembles this type of functions. So once you understand mathematically how to do chain rule, product rule, quotient rule, you can do anything. You can do this type of formulas in your nature. So this is 3u over 2. I know when the v equal 3u over 2, the derivative is 0. That means you have a horizontal tangent line. Okay, now I need one of you choose something less than this. Anybody tell me something less than that? This is 1.5u. Yeah, just u. And this is 2u. It's good. This is my extrema. I choose like last time. Remember when we get 3, you choose 1 and 4, like that. Okay? So okay, let me put u. So I'm going to put u instead of v. Remember my axis is v, right? So what happens if I put u here? Anybody? Is it plus or minus? Plus. If you put u here, what happens if you put u? This gives me minus. Clear? So it's minus. So that means here less than your extrema, the derivative is negative. What happens if you put 2u? If you put 2u, The derivative is positive greater than that. Derivative negative means decreasing. Derivative positive means increasing. That's how it's minimum. Okay? The minimum happen at 3u over 2. Alright, I think this is a good question. Okay? You can explain the graph. This is energy. These are the question, problem you draw really in your physics class or engineering class. Okay? So energy cannot be, the velocity is not, or the speed is not negative. So it's always, you think about the first quadrant, on the positive side. Okay? What happened V0? No energy, because the fish is not swimming, so no energy. You can start from here. Okay? V is always greater than u. Okay? So this is u. Let's say u. You don't draw anything below u. You may ask why you don't draw anything below u, because this condition or this application only valid my v is greater than u. Clear? If v is less than u, like fish is dying, it's probably the current. Okay, nothing below that. Okay, this is where you start, and it does not exist. All right, that is like asymptote. Everybody agree at v and u equal, we have asymptotes. It's a rational function. You learn rational function in pre-calc. So that's why you learn rational function and you know the domain is always greater than u. Your v is greater than u. The domain is greater than u. When u and v equal, you have a problem, like vertical asymptote. Right. So and I know 2u over 3u over 2, this is 3u over 2, and I have a minimum. Okay? So it's kind of coming like this. Right. Let's see. The fish is smart enough to choose this velocity. So that's the beauty of biology, beauty of the nature. Actually, the nature. Fish doesn't need to do calculus, but see how beauty that they figure out what is the speed, what is the optimum speed to swim a certain distance. Right. Can you find what is that minimum energy and then you stop? Okay. That's not asking the question, but you can find that minimum energy. This is the minimum energy. Fish has to expend energy expenditure for unit time. It's me, right? Yeah. What is the minimum energy expenditure? What do? You plug 3u over 2 instead of v. Okay? Because this is because this is the energy E minimum. This is the energy at v equal this. Clear? Let me write it like this. To find minimum energy, E mean minimum energy, set the speed of the velocity of the fish is equal to 3u over 2. 3u over 2 is like 50% more than the current speed of the current. Okay? So I'm going to plug that. Actually, you find plug. It's still not. You can plug, yeah. Is it clear how I was plug to plug? and you can't cross that. It's going like, you never cross this line. Okay? Because you don't draw anything here. Because of this condition. My V is always greater than U. Okay? And how? So AV cube L. I want to plug V as U. I can say A 3U over 2 cube L. What is V minus U? V minus U means you subtract U from this, which is U over 2. So you get E minimum, this is extra, okay? 27 U cube AL. This will be 8, you go down and cancel with this 2, it's 4U. The U and U cancel out, it's 27 U2AL over 4. This is 27, this is U cube, but you cancel with U, so it's U to the power 2. This is 8 coming down and cancel with 2 gives you 4. So if you want to really know how much the fish, spend, how much the energy it spend, this is the energy it spend to travel SL distance. Okay. And with the U stream speed. Okay. So everything is. All right. Let's put this. So if you have any question in your major, you will feel like interested and to want to have it with your friends, bring it to the class and I am happy to discuss. Okay? Any question related to calculus? Okay? Right, so probably Friday, tomorrow we will start optimization question. First, more question like this. Maybe easier than this, okay?